Start. Okay, now the third physical quantity is maximum height in a ground to ground projectile motion. Now remember, at the maximum height, y component of velocity is 0. So we know the kinematics formula, v square is u square plus 2as. Apply this formula along y direction. So vy square should be uy square plus 2ay sy. Vy is 0, uy is initial vertical component of velocity, that is u sin theta. Ay of course minus g. Sy is h max. So from here h max can be calculated, and it is nothing but u sin theta whole square divided by 2g. U sin theta is called initial vertical component of velocity, or y component of initial velocity. Next is the time of flight, that is the time during which the particle is flying, or time taken from point of projection to the point of strike. Remember, at the point of projection y coordinate is 0, and at the time of striking again y coordinate is 0. So can I say at t is equal to 0, at time t is equal to time of flight, y coordinate has to be 0 because both are on the x-axis. And again the displacement along y-axis, already y coordinate calculated, y is equal to ut minus half at square. So u should be initial vertical component, that is ut minus half g t square has to be 0. Remember, I have taken y component because y coordinate has to be 0. From here I will get two values of time, one is 0, one is capital T. 0 means initial time. We are interested in total time of flight. So t should be 2u sin theta by g, or twice by g initial vertical component of velocity. That means we got the maximum height, and these are standard results. We got the total time of flight. The next is what is the range? Range is nothing but displacement along x direction in a time equal to time of flight. So apply the displacement. Displacement in the x direction, nothing but x coordinate. Again remember, s is equal to ut plus half at square. Apply this formula in x direction. So x becomes uxt plus half axt square. What is initial component x direction? U cos theta. T becomes time of flight. No acceleration in x direction, so this expression is 0. End result, range is u cos theta into time of flight. Time of flight already calculated. Put the value, you will get the expression for the range, that is u square sin 2 theta by small g. And finally, that is called equation of trajectory, or equation of path which the particle is following. Remember, equation of trajectory is nothing but relation between x coordinate and y coordinate of the particle independent of time. Now already we know its x coordinate at a time t is u cos theta into t, y coordinate at a time t is u sin theta t minus half g t square. Now we have to find a relation between x and y independent of time. So from equation 1, time can be calculated, and this time will be x by u cos theta. Now put this time in equation number 2, you will get y is equal to x sin theta minus g x square by 2 u square cos square theta. And this equation happens to be a parabola. That's why projectile motion is sometimes called parabolic motion. Now in case of projectile motion, that is ground to ground, there are 4 standard results that we are supposed to know. Now the question is, what are those standard results? Now the results are, remember, in this situation, initial speed and initial angle of projection will be known to us. Time of flight is always 2u sin theta by g, or 2 by g initial vertical component of phi. Remember, maximum height u square sin square theta by 2g, or uy square by 2g. Again, uy is called initial vertical component. Range u square sin 2 theta by g, or 2 by g x component of initial velocity multiplied by y component of initial velocity. Equation of trajectory, y is equal to x sin theta minus g x square by 2 u square cos square theta. Now this expression can also be converted like this, because 1 by cos square is sec square, and sec square is 1 plus tan square theta. So either this formula or this formula. Now the equation of trajectory can also be manipulated in terms of range. So if you manipulate, then trajectory equation can also be written like this. Why it is important? Because sometimes angle of projection is given, range is given, and question demands what is the equation of trajectory. So in this situation, this formula can be directly utilized. If u is given, theta is given, then this or this can be utilized. But when u is not given, but theta and range is given, then it is always better to utilize this one. So in case of ground to ground projectile motion, these four results are very standard and one has to remember. That should be very clear. But again remember, in all this derivation, theta is the initial angular projection and it is taken from the horizontal direction, that is x direction. Okay.